Space, the final frontier, a place of boundless exploration and untold mysteries. Yet, amid the wonders of the cosmos, humanity faces a growing and invisible threat: space junk. As we send more satellites and spacecraft into orbit, Earth's atmosphere becomes littered with discarded rocket parts, defunct satellites, and debris from past collisions. This isn't just an eyesore in the vastness of space, it's a ticking time bomb. How did this problem begin? The story of space junk starts with the dawn of the space race. Since the launch of Sputnik in 1957, thousands of satellites, rockets, and spacecraft have been sent into orbit, but not everything that goes up comes back down. Many satellites are abandoned after their missions, left to drift in space indefinitely. In 2007, China's anti-satellite missile test sent shockwaves, both politically and physically. The destruction of one satellite alone created thousands of fragments, each now a high-speed hazard. Then, in 2009, two satellites accidentally collided, creating a cloud of debris that still circles Earth today. Today, there are over 30,000 pieces of debris larger than 10 centimeters being tracked by space agencies, but there are millions of smaller fragments we can't monitor. These pieces of space junk pose a serious threat to active satellites and missions, including the International Space Station. Every day, satellites help us communicate, navigate, and observe the planet. But these same satellites are at constant risk of being damaged or destroyed by even the tiniest piece of debris. The speed of space junk is astounding, traveling at up to 28,000 kilometers per hour. At these speeds, even a fragment as small as a paint chip can puncture metal. In 2020, the ISS had to make 3 emergency maneuvers to avoid catastrophic collisions with space debris. As space travel and satellite launches increase, so does the danger. But why is space junk so dangerous? The physics behind it explain why every fragment, no matter how small, can cause immense damage. In the vacuum of space, there's no atmosphere to slow down debris. A single bolt or piece of metal travels at speeds faster than a bullet. When these fragments collide, they shatter, creating even more debris. This is where the real problem begins. Scientists call it the Kessler Syndrome. A single collision can create a domino effect where more debris leads to more collisions, eventually making Earth's orbit a perilous obstacle course. Space agencies around the world are aware of this growing crisis. NASA, ESA, and private companies like SpaceX are working on ways to monitor and mitigate the debris problem. Ground-based radars track larger pieces of debris, helping spacecraft avoid dangerous collisions. But avoiding is not enough. Solutions for cleanup are critical. From giant nets to robotic arms and even harpoon-like devices, scientists are exploring technologies to capture and remove debris from orbit. One of the most promising solutions is to design future satellites with deorbiting capabilities, so they can remove themselves once their missions are complete. Another innovative approach involves using lasers from Earth to nudge debris out of harm's way. But while these ideas offer hope, international collaboration is essential. No single country can solve this problem alone. To prevent further damage and avoid the nightmare scenario of Kessler Syndrome, countries, space agencies, and private companies must work together. Space may seem infinite, but the regions closest to Earth are filling up fast with dangerous debris. We are at a tipping point. Without immediate action, the space we rely on could become a no-go zone, threatening our satellites, missions, and even our dreams of further exploration. The truth is clear. Space junk is no longer just a problem for astronauts, it's a problem for all of us. But with innovation, cooperation, and swift action, there's still hope to keep the final frontier open for discovery.